Welcome to Off Hours, a conversation between John Edwards and Chris Manning.
So, John, we're very fortunate to have some very dedicated listeners that listen to our podcast on a regular basis. And thank you, listeners, to everyone who does in fact listen to the show on a regular basis. But we have a particular class of listener who, they can be a bit problematic sometimes. And I'm thinking specifically about someone who shall remain unnamed, but I share a shop with. And I did receive a little bit of late night follow-up. Someone was walking around the neighborhood listening to us. We got a little bit of follow-up about our gauge block talk on the last episode, specifically when it came to the units of force that we were talking about when we were talking about separating two gauge blocks that had been rung together. You want to explain what we did wrong there?
I think the feedback was absolutely warranted, and my apologies to all the engineers and physicists out there. I said Newton meters. I led the whole conversation astray, and Chris followed up and said Newton meters as well. That is a measure of torque, and I don't know if subliminally the ringing motion of the blocks led me off, but it's just straight up newtons. It is not torque force at play that we were talking about physically pulling the blocks apart.
Yes,
which is a tension force, and that's just straight up good old fashioned newtons.
And I hadn't even noticed it when you said it, and I didn't even think about it again after I had edited it numerous times, and then of course our pedantic listeners brought it up to us. So thank you very much, Mr. Lowen, for
our highly astute and well informed.
Well, yes, it was, but it was lying there at 11:30 at night in my bed, reading the news and getting a text message saying it's newtons, not Newton meters. Anyways, thank you, Rich, for bringing that to our attention.
And my apologies to everyone. I'll get it right next time. It's funny how you can have a slip of the tongue like that. One that I'm surprised I still hear like long-time vetted watchmakers make a slip of the tongue on from time to time is just like hairspring and mainspring. I mean, they're two very, very different parts of the watch.
No, I do it all the time. I have to think about that every single time I talk about the hairspring or the mainspring, because in my brain, I don't know what it is, but I'm always mixing up the words for the two. I know exactly what it is that I'm talking about. And for whatever reason, my brain decides to spit the words out for the other one. It drives me crazy. But, fortunately, that's something that I can edit out of the podcast, and I can, because I usually catch myself and I edit out the slip. But yes, I do that constantly, and I don't know why.
Well, you're certainly not alone in it. I hear it all the time, and I'm certain I've done it myself unknowingly. Yeah. I think it's because it's two simple, well-trod four-letter words followed by spring.
Yes, exactly. So it's very easy to do. Now, speaking of our listeners, we do have listeners who've been with us since day one, and thank you very much to those of you who've listened to all 75 episodes of us over the last 3 years. It's nice that we've had people following along for so long, and I know that we've had a number of people who've told me that they've gone back and listened to some of our back catalog and have enjoyed that. But shout out to Robin Renzetti, who this week on Instagram let me know that he's just recently gone back and listened to the entire 75 episode back catalog of Off Hours while he was working in his shop over the last few weeks. And frankly, that's impressive. I'm not sure that it's something that I would recommend to anybody, but thank you very much, Robin. And for those who don't know who Robin is, he has a great Instagram feed and YouTube channel that is really worth watching if you are interested in all things precision when it comes to machining. Robin is a wealth of knowledge when it comes to ultra precision machining, certainly stuff far beyond what we're doing even in watchmaking. And he's very generous with giving his knowledge out to the world through the videos that he does both on Instagram and YouTube. So if this is the kind of thing that you're interested in, precision and how to machine things in precise ways, go over and check out Robin's Instagram feed and YouTube channel. We'll put links in the show notes. They really are worth watching, but realize that you're in for a deep dive. Robin is incredibly knowledgeable and really does a great job of explaining what it is that he's doing and why it is that he's doing it.
I'm honored. Thank you, Robin.
And speaking of machinists, my mostly tame machinist that I use here in town when I don't know how to machine something or I need an answer, Paul Burberry, friend of the show. He's someone we've been chatting about over the years, and is currently working on a project for me to make some new pattern bars. We were thinking about trying to get him onto the show, so maybe in the next episode or two we'll have a conversation with Paul. And not sure exactly what we'll get up to talking about, but I'm sure we can figure out some interesting things to pick Paul's brain about.
Oh, I'm sure, absolutely. Go all sorts of rabbit holes we could dive down talking machining for sure. So another bit of follow-up. You were doing a bit of research, or what is it, experimentation possibly with laser engraving of Sapphire this week?
No, I didn't actually try doing any laser engraving. I was at home for a couple of days and bored watching movies, so I was doing some research on the interwebs and looking into what's required to do laser engraving on Sapphire, because that's something that we've sort of mused about over time. And a few watch companies are doing it regularly on their watches. We talked about Omega and Rolex, who have their logos on the crystals. And I was kind of curious to see whether or not the fiber laser that I happen to have, how close that was to being able to actually do that kind of work. And two things that I was able to figure out from it. I didn't find a lot of good information on, formulas and stuff like that for doing it, but a couple of companies that are selling lasers specifically for doing this kind of work. A few things that I noticed. The first is that the wavelength of light is completely different than what I'm using. I've got a 1064 nanometer laser in my fiber laser, and the lasers that are being used to engrave Sapphire are in the 355 nanometer range. So very different wavelength of light. I'm not, my optical physics knowledge is pretty low, so I don't know how much of a difference there is in that, and, whether there would be a way of getting around it just, at a lower frequency like what I'm using. But I suspect not. I know that when you deal with the differences between, let's say, like a CO2 laser and a fiber laser, like the one that I've got, the CO2 lasers are the ones that are pretty common that a lot of people have in their shop or, at their local maker space or whatever. And those are used for cutting paper and wood and leather and things like that. A lot of organics. That sort of thing is a very different wavelength than the fiber lasers that I'm using. And I know that wavelength change allows you to impart significantly more energy into what it is that you're engraving. So I suspect that the change from 1064 up to 355 is probably, a significant change in the amount of energy that you're actually distributing into that area. So that's the first thing. The wavelength of light is very different. And then on top of that, they're using Q-switched lasers, which allows you to make some changes to the pulse rate, I believe it is, of the laser. Mine has a constant pulse width I can change it, but it's a constant one as I go. And there are Q-switched lasers that are in this kind of frequency that I've got. And that allows you to do some fun things like doing different colors on stainless steel or titanium and things like that. Like you can actually control those colors actively. So you can make a bright yellow beside a blue, beside a green or whatever on a stainless steel part. So Q-switch lasers are pretty cool. And it's sort of the next generation of the technology compared to the one that I've got right now. But it's not really all that important for the stuff that I do. So I didn't consider it, especially considering you're often paying a $20,000 premium for that Q-switch technology. The lasers that I saw, of course, none of them have price tags on them on the website. It's please call us for details
if you have to ask.
Yeah, so I suspect that they're pretty pricey right now to do that kind of work. I don't know how flexible they are in doing other work, so certainly not something that I'm planning on looking into anytime in the near future from a price point of view.
Mm-hmm. Oh, it's incredible how far laser technology has come in just a little over half a century.
Oh yeah,
and what's particularly impressive to me is that Rolex has been laser etching their sapphire crystals since the mid-90s. So it's like going on 30 years now.
Yeah, that leads me to believe that there's probably ways of doing it with I'm not going to say more primitive laser technology. I don't think that's really the appropriate way of putting it, but earlier sort of generations of the technology. I mean, obviously the one that I'm running, it's become a more of a commodity type tool. And so that's obviously gained off the backs of what Rolex was doing 20 odd years ago. So there probably are ways of doing it. It just may be incredibly inefficient, or there may be, serious limitations in how to do it or whatever. But if anybody out there is familiar with it or knows how to laser engrave sapphire with a 1064 nanometer fiber laser, let me know. And I'll probably still give it a try at some point as well, just to see what actually happens and see if it, if it actually can work. From what I gather, I think that what it's doing is it's creating microfractures in the crystal structure, and so therefore diffusing the light that you've got going through there. And so you're also dealing with other problems because you don't want to put those little tiny fractures too close together, or else you will create a large fracture line, and you'll then easily crack the part. You find people doing these photos, sort of floating photos in an acrylic block or whatever.
I have one of those.
Do you really have one of those?
I have one of those.
Yeah, don't drop it. It's that's all fracture lines that are in there that are causing that photo to be created. And I suspect it's probably a very similar thing that's happening with the Sapphire. So you would want to make sure that your fracture points are very, very tiny. And so obviously as you go up in frequency, you're also decreasing the size of that laser point, and therefore, being able to do a finer detail engraving in the part. So, yeah, I would be surprised if it's something that I'm able to do with the laser that I've got.
I had no idea those were made of acrylic. Actually, I thought they were glass. Yeah, I've had a portrait of myself gifted to me for my 21st birthday years ago when I was living in England, and actually had it done there in a little toy shop. Well, little it's kind of the wrong turn of phrase, but the biggest, most famous, most prolific toy shop in London, England, Hamleys. And up there, like the second or third floor, they had one of these little booths, and you could get a scan of yourself done in 3D. Yeah. And then you end up in one of these little crystal
blocks.
Yeah. For lack of a better term. I actually thought it was quite neat, because at the time I was writing a paper on the Parthenon marbles, and some scanning work that was done on those to preserve them digitally, and the exact same techniques that they had used to carry out those scans is what was blasted at me in order to render me in these series of small points in that crystal block. And similar tech was actually used for the Matrix too, and some of the stuff that they pioneered, doing these really neat bullet time stuff, and sweeping through the cities and scenery and whatnot.
Yeah, and I say that they're acrylic blocks because these days that's what people tend to be using for it. But I do know that various glass blocks have been used for it as well. You just have to make sure that the crystal structure of it is solid. A lot of people these days are doing them out of acrylic because that's obviously far less expensive than doing them out of glass. And it wouldn't surprise me if the one that you have is glass.
It certainly has heft to it that it is not acrylic in nature.
Absolutely, yeah. So it's I don't mean to imply that that's the only thing that they're being done with, but certainly most people these days are doing it out of some kind of an acrylic just because it is far less expensive and probably easier to get that crystalline structure that they need for the laser.
And because of the limitations of the scanning technology that was being used, I couldn't actually strike the precise pose that I wanted to, because you have to be able to see all the dimensionality quite easily. Yeah. So if you were to do, say, a closed hand, or try and put your hands in front of your face, then all of a sudden there's just going to be this gap behind your hand where like your face is completely not there inside of the render or the rendition that is done inside of the glass or the acrylic with all these little microfractures. And it's interesting too to make this parallel. It's not a connection I've ever made before, but the insignia on the Rolex crystals that are done in sapphire, it's not straight lines. It's pointillist style,
Sure.
the exact same way that these images rendered inside these crystals are. It's just these little tiny dots that are made, and then as you join those all together in sort of the pointillist style of painting, you stand far enough back, and it becomes an image.
Exactly.
So it's the exact same thing with the insignia on these sapphire crystals. It's a whole bunch of tiny little points in the shape of a crown. And then if you happen to have your crystal replaced at some point, then you'll end up with a little tiny S down in the very bottom of the crown.
Really?
Just to signify that it is a replacement crystal. So it was a service crystal, not original from when the watch left the factory.
Oh, there you go. All right, I didn't know that.
And speaking of machining as well, we finally cut some metal on Project Minotaur.
Yeah, it was really nice. We Monday night we were able to actually sit down and start working on the movement itself. It went a little slower than I was hoping it would, mostly because we needed to troubleshoot a couple of problems and make a couple of little jigs and modify some tools and things like that. All the kinds of things that you expect to have to do at the beginning of any project that you haven't done before. So we spent a couple of hours drilling out the pinholes for the new bridges and cocks, and it was a good time.
Mm-hmm. And it turned out your wobble stick was indeed just a little too long.
Oh, yeah, and I was expecting it to be too long. A 36-inch long wobble stick was a little ridiculous for a 1/8 inch rod. So we did cut that down, and I guess now it's probably somewhere in the 14 or 15-inch range in terms of length. It's incredibly effective. I still think it would be nice to have a longer one, just to be able to get a little bit more accuracy on things like jewel holes. It's certainly a nice tool to have. And it does take a little bit of getting used to, particularly on a small lathe and, and a fiddly faceplate that neither of us are used to and things like that. But it is incredibly effective at being able to center things.
Mm-hmm. And I think if you were to go longer, you would have to get a larger diameter shaft, because even with it trimmed down, I'm still pretty sure it was picking up some resonance from Daft Punk playing in the background, and that the bass from that alone was serving up a minuscule amount of wobble as we were dialing it into perfection.
It's certainly not the perfect workshop in terms of stability of the machines and everything. This is on the second floor. It's just a joist floor that's underneath it, and it is a steel joist floor, but still it's a joist floor. The floor does bounce a little bit. You get some music going, and all of a sudden you can see little vibrations and things. So it is certainly not the absolute perfect place to do it. If I could, I'd put it on a nice solid concrete pad, and although even then we're right beside a major roadway, so you're still going to get vibrations from traffic going by and things like that at certain levels. So, but it's certainly good enough for what we were doing here, and it was easy enough to see when we were still out a little bit and when we got it right on and got it bang on.
And with any long rod like that, even just sound waves will be enough to throw it off. I had a helicopter fly a little low overhead the week before last at the house there, and it actually set off the chimes on my grandfather clock, which has never happened before.
Well, that was a chinook that went overhead, and I know that because I heard it over top of my music while I was in the shop. I was working on a milling machine with noise-canceling headphones in, and I could feel the vibrations from that chinook flying over top.
Mm-hmm. It was palpable.
I know that I was speaking to an old-school engine turner at one point who did some work for a firm in London, and they had all sorts of problems with some of the really fine, detailed engine turning work that they were doing where having traffic outside was problematic. So there was certain work that they only did after hours when they didn't have people walking down the hallway. And, that can certainly be problematic for you if you're doing very, very high precision work or something where you can see those vibrations like a super polished surface, which is what you're going to get out of something like a straight line cut.
Yeah. So when you start to do any sort of really fine precision work, and the smallest perturbances can start to show up. Actually, a neat little anecdote that came up a couple months ago that was relayed on the Minutia Repeater podcast was David Walter dialed in one of these clocks that he's working on to an incredible level of precision. but he was noticing this sort of unusual deviation in timekeeping that he just wasn't able to pinpoint what the root cause was. And he's got these clocks dialed into the point that they're quite literally working like a Richter's scale would, in that it will actually pick up very small tremors and earthquakes, and even just the shocks from far off earthquakes will show up in the timekeeping and the rate of the clock. And he's fairly accustomed to noting these sorts of things and being able to attribute different deviations in timekeeping. But one that was niggling at him turned out to be just someone going to work in their big boxy SUV every day at the same time, and it was just showing up as a blip on his timing machine. And just that turning the corner by his house, that vehicle and its engine was just big enough to cause some trouble for the timekeeping on that piece.
Yeah, it certainly can be problematic, and it's one of the reasons I haven't done a lot of engine turning in the last few years, because the engines were living in my living room, and again, sprung floor, and they just, anytime you got them going, the whole floor bounced, and you could see the vibrations from the floor, show up in the cuts that you were working on. So it's something that you have to be concerned with. A lot of the stuff that I do, it's just not an issue. I don't, it's not enough of a problem as long as the floor is stable enough to be able to, to do the thing that you're doing, then, or to hold the machine that you're working with. It's, that's going to be fine. But for some things, especially the engine turning work, that's hugely problematic for me.
So you would actually pick up perturbations in the patterns that you were creating when that would start to happen?
Oh yeah, absolutely. So I like to listen to music when I'm engine turning. I like to be able to sort of drown out what else is going on around me, just because it's very, very easy to make mistakes while you're counting and if your pattern is off by a couple thou, it's obvious in an engine turned piece. So I like to listen to music and sort of drown out the rest of the world. And I have to listen to it on headphones because otherwise, even if I've got it on music on quietly, it's enough that I can pick it up in the parts that I'm engine turning. So you can actually see the little vibrations in the cuts as you're looking at it under a loop. And certainly it's something that you have to be cautious of and be conscious of when you're doing certain types of work like that.
It actually makes a lot of sense because you are, in effect, cutting a record.
Yeah.
Right? It's just like vinyl records. That's exactly how they work.
Absolutely.
It's just picking up those slight variations in the air that's caused by sound and relaying that into a physical solid.
Yeah. In this case, the needle is 1,100 pounds of cast iron, and the record is a very, very highly polished surface that's showing up in your cut. But it certainly does show up. Now, this is one of the reasons why I suspect a lot of watchmakers, especially classic watchmakers like Breguet, were actually frosting their engine-turned dials. And one of the things that happens when you frost your dial like that is that you actually lose a lot of that detail. And because it's no longer a very highly polished surface that you're seeing in there, you don't actually see all those tiny little vibrations that show up in the engine-turned cut. So I suspect one of the reasons, today people do it because that's the classic Breguet look. It also helps with preventing it from oxidizing more. But on top of that, I suspect a lot of that was done to hide some of those little deviations in the cuts.
Just a point of clarification for my own curiosity. When you use the term frosting there on Breguet's dials, that's not a term that I've heard used applied to his work before. Using that term sort of interchangeably with bleaching. Or is that a sort of common turn of phrase within engine turning and guilloche work? No,
I'm referring to it for that way because that's sort of what a lot of jewelers would call it. And I've heard jewelers referring to it as frosting. But you're right, bleaching is the same idea, where you're taking, in this case, typically what you're doing is you're heating the dial, and then you're putting it into a pickle solution, an acid solution. And there you're actually bleaching out a lot of the metals that are at the surface. But the other side effect of that is that you're also dulling the surface. You're taking it from a very high polish down to down to a lower polish, just because of the reactions that you're getting. If there is any copper in the metal that you're working with, a lot of dials are being made out of fine silver, so there probably isn't going to be a lot of copper. But typically that's going to get pulled to the surface as part of the heating, and then the acid solution, the pickle that you're using, is actually going to dissolve that copper from the surface, and you're then going to end up with a pure silver dial there. This is one of the techniques that a lot of enamelists use when they're enameling sterling silver. So sterling has 7.5% copper in it, and typically you want to be enameling on top of pure silver. And so a lot of people will do this bleaching technique, this frosting technique, whatever you want to call it, and they'll actually repeatedly heat the part and then put it into a pickle solution, and they'll actually bleach that out. You'll also see people do this to remove fire scale, which is sort of a dark gray mottled sort of stain that you see on sterling silver, and that's something that you get when you don't protect it properly from oxygen when you're heating it. So it's actually a sulfur oxide that's being formed on the silver, and again, with the bleaching process, you can actually bleach out some of that oxide, and you can get back to a fine silver surface. And so a lot of people who do raised work, like hammer work, where they're actually raising volumes out of sheet silver, again, they're not necessarily going to cover the entire piece with with flux or something like that or borax or something like that while they're heating it. And so to avoid the problem of the fire scale, they'll go in and they'll bleach it afterwards so they don't have to deal with that.
So have you ever bleached any of your guilloche work, or do you always leave that bright clean cut?
I have done it to see what it looks like, and I'm not a big fan of the look of it. So my stuff will probably not be bleached. I know that's the classic look, and I know that's what a lot of people are doing, but I probably won't be bleaching mine. I am going to do some other work on the rest of the dial in order to distinguish things like the chapter ring from the engine turning and get a texture difference, as well as probably a reflective difference. It's not going to be quite as shiny, but I don't think I'm going to be bleaching mine.
So using the wobble stick certainly wasn't as expedient as using a precision drill press or a precision mill would have been for drilling out the holes.
Mm-hmm.
In terms of the tools that were at our disposal in the moment, this was by far the most precise way to go about drilling these holes, and it was very time consuming. You're certainly not going to mass produce any watches using a wobble stick, but it was great to get back in there and do this again. I probably doubled the number of times I've used a faceplate in my life, doing just this one task for the number of holes that we had to drill out. And typically I'm just centering a jewel up and doing some work or a bushing or something like that, just to do a repair or some restoration work. But it is actually quite infrequent that I've needed to use a faceplate for a lot of the work I've done over the years. So it was great to get in there and to do that.
Yeah.
And two little machinist techniques or tips that you brought to the table that I appreciate, and I think worth sharing for anyone else out there who might not have thought to do these things, was one, for the reference for the wobble stick, you actually used a machinist square.
Yeah.
And I think part of the reason I never thought to do this is because the machinist squares that I have are so petite, almost like play toys compared to a lot of the machinist squares that you have around the shop.
Yeah.
But I think my largest one's about 5 inches. But you have
slightly larger ones,
just a little bigger. And you set this up on its side to use as the reference point. Whereas I've always just used a metal ruler in the past. And I physically hold the ruler in place while I work at figuring out, where I need to make my next adjustment. I'll set the ruler down, make my few little taps and set the ruler back up.
I was going to say, that's great if you have 3 or 4 hands, but if you've only got 2 hands like normal people.
It's totally feasible. Totally doable.
But you can't see what you're working on as you're doing it, right? The nice thing about having a stable reference point like the machinist square is the fact that you can actually see what's going on as you're working, and you can tap it. You don't have to sit there and go and hold the scale up and then go and turn your headstock and then go back and do it like that. Like it's nice to have a stable thing that's there to have as a reference point.
Mm-hmm. Yeah, absolutely. And you're planning to take it a step further too.
Yeah, one of the things I decided was that I've got this nice laser engraver downstairs. Why not laser engrave a scale onto it? So I'm experimenting with a couple of different sort of target designs with graduations on it. So there's a couple of circles with crosshairs on it, and then some little lines delineating different distances from the center of it. And we'll see. Mostly, I'm not so worried about exactly how far apart they are. I mean, they happen to be 1 millimeter apart for most of the scale, and then a 0.5 millimeter apart at the very center. But the actual distance that they are from each other is kind of unimportant. It's more that they are consistently separated and they present a nice point of reference. So you can actually see the point of your wobble stick as it's being, as it's wobbling back and forth in front of the scale. So that should make things a little bit easier. Yeah,
I think scale could be a bit of a misleading term there. So you used it twice, and your description was a little more on point. But yeah, it's more akin to say a bullseye or a gun sight.
Yeah, it's more like it's more like the overlay that you see in a scope on a rifle, for instance, where you're actually getting getting these little deviations from the center and as you're going both horizontally and vertically, because the wobble stick does deviate both horizontally and vertically. So it's nice to be able to see that deviation. And depending on what it is that you're doing and what you're most comfortable with, sometimes it's easier to look down on the top of the wobble stick and see it deviating side to side, and sometimes it's easier to look from the side and see it going up and down. Just whatever you're most comfortable with.
Mm-hmm. And in that regard, the other point I quite appreciated was from all of your years centering things in a 4-jaw chuck. I've always just targeted the lowest point of the wobble stick and made my adjustments from there. But you pointed out that you could wind up chasing your tail quite a bit doing that, and that it's actually far more expedient to just work at 180 degrees from each other and just check those 2 points. Don't worry about anywhere else, and it doesn't matter about the side to side. Just focus on those 2 points, and as you dial in those 2 points, you're going to just pull everything in together quite a bit faster, and then worry about fine-tuning your 90-degree angles from there rather than always chasing that lowest point.
Yeah, one of the things that I learned early on with a 4-jaw chuck is that if you imagine you've got four different jaws that you can independently adjust on a 4-jaw chuck, and if you imagine they're labeled 1, 2, 3, 4, let's say clockwise, you're best off adjusting, let's say 1 and 3, because they're opposing jaws. You're better off adjusting those two, getting it centered in between those two jaws, and then, or at least very close, and then going to 2 and 4 and adjusting those. And then you can go back afterwards and go back to 1 and 3 if you need to, and get close again. One of the nice things about working on just a single axis like that is that when you get very close to it, you actually know where it's going to be, where that center point is. Now, in our case, we're using a wobble stick, so that center point is obvious because it's not moving around anymore. But when I'm working on a 4-jaw chuck, typically I have a dial indicator that I'm working with. And when you first start using the dial indicator, you don't know where your 0 point is. But once you've sort of centered one axis, you now know where 0 is, which then makes it much faster for you to adjust the other axis, because now you know on the dial indicator what 0 is and what you need to target. And so you can then very quickly move it into alignment. And it's a much faster process than trying to chase around 1 and then 2 and then 3 and then 4. And then you can spend a long time chasing that around like that.
Mm. I think part of the reason that something that never occurred to me clearly is because I never worked in a machinist shop. But the other reason too is I'm usually working with round plates.
Yes.
And one of the nice things about working on this sort of 180-degree axis, single axis, was that we actually had a square plate affixed to a round plate. So you just chose your axis based on a flat edge, and that gave you a very nice surface to gently tap down on to dial in that perfect concentricity.
Yeah, the square plates that we're working on, they are the plates that are going to eventually become the new bridges and cocks on this watch. And yeah, they're still square. It's easy to use those as the reference points. But even if it wasn't, even if this had been a perfectly round piece, I would have, possibly marked on the faceplate where the 4 points were, and I still would have worked like that because it is much easier to do that, and that way you're not sort of sitting there chasing around. And it's worthwhile picking, let's say, the low point as one of your axes, but from there you want to work across from it and continue doing that until you're able to dial in at least one direction, and then you can get to the next one, and it goes a little faster that way. We've talked a little bit about the wobble stick and what it does and why it's useful, but we did run into a situation where the wobble stick didn't actually help us out.
Yes, this is quite a common problem when working with a main plate, even just when installing and extracting jewels and other fairly common tasks. Is sometimes you'll have an area where you don't have a flat surface to work on the jewel hole.
Mm-hmm.
Generally speaking, in well-designed calibers, at least one side of the main plate will have a nice surface for you to rest your tool flat up against to work on the jewel or the hole in a precise manner. One of the holes that we needed to drill out was in a place where halfway through the hole had been milled out a section of material. So we didn't have a full circumference to work off of for the wobble stick. So the route we tried at first was just to use something from the staking set to get that as close as possible to being centered on the faceplate. And that got close, but not quite close enough.
Yeah, the staking set that I have, I didn't have anything that had a nice square-sided shoulder to it, that would fit in there. So we were using something that had a taper to it, and a taper just wasn't quite enough. It wasn't
not ideal for the job.
No, a taper isn't really a great thing in that case to center something up. So that really didn't quite work out perfectly.
So then Chris ended up machining a specific piece of drill rod for the purpose, which is what I had in mind when I had first recommended using the staking set, because some of the staking sets I have at my disposal, but they were not close at hand at the time. I have a straight shoulder on them, and they come down to a very fine point. So Chris was able to grind, actually, on his precision grinder, a very precise shaft, and was able to use that in order to get that hole centered in the faceplate, and then we could drill through to the accompanying side where a new pin would be placed in the accompanying bridge.
Yeah, it's nice having access. In this case, I was using a tool and cutter grinder, which isn't something that a lot of people have access to anymore, but they're relatively common. And these tool and cutter grinders are great if you're trying to do work like this. I use them all the time for grinding lathe tools and also end mills occasionally if I need to make either sharpen an end mill or maybe make something that's a little bit more custom. In this case, it was great. It's very easy for me to be able to make things like dead centers with it, or make a straight-sided pin that was exactly 1 millimeter in diameter. So it was very, very easy for me to go in there and do that and make that. I didn't end up hardening this one, but I think I'm going to go back and regrind it and actually harden it, because now that I've seen it in action, it's going to do exactly what I need it to do, and it'll be useful in the future for other kinds of work like this, where maybe I need to be able to get in there to a 1 millimeter hole and actually center it properly. I'm not sure that I would use that as a way of centering, let's say, a jewel hole. I don't think it would be quite accurate enough for a jewel hole. But for this kind of work with a pin, where we're enlarging the hole that's there, and we're drilling into the fresh metal in behind for the location for the new pin, it works out fine in this case because we're drilling both holes simultaneously. They are co-located and concentric, and we don't have to worry about it from that point of view. Again, if we're going into a jewel hole, or if we were trying to line up with an existing hole to drill a new one for a jewel, I wouldn't trust it. But for this, it was fine. It gave us a level of accuracy that I'm comfortable with. And you can see if you look at it with a loop, you can see that it's just ever so slightly off. But again, it won't be a problem because the pin will line up perfectly with this new hole that we've managed to enlarge.
Another nice little tip in this vein as well, just to save time working with the tailstock, is to make little helper tools like this out of rod that's the exact same diameter as the drill bits that you're using. So all the tungsten carbide bits we're using have an 1/8" shank on them. And so making these other little pieces you can just slide right in there and not have to worry about changing out the collet was nice to expedite things along as well. Anything from like a centering rod to a custom tailored, I want to say jig. Is jig appropriate in this?
Yeah, it is a jig, a pin.
A custom tailored jig or pin or gauge pin in this particular case.
Yeah, one of the things that I found, especially with this lathe, the Derbyshire lathe, this is the 750 model. All of the Derbyshire lathes are similar. They use a collet in the tailstock as well as in the headstock, which is nice because it means that you can get very, very precise holding in the tailstock. And if you're going to be using a collet system like that, you don't want to be changing collets all the time. And so you don't want to go from one collet for your drill bits to a different collet for your dead center to a different collet for your little jig that you've made to hold a 1 millimeter hole precisely. In this case, I've got 1/8" drill rod that is convenient, and I've got 10 feet of it or whatever that I can quickly make up little 4 or 5 inch long tools, and they all fit into the 1/8" collet, which is what these PCB drills are all shanked to, and it just makes life very, very simple and certainly a lot faster when it comes to working on things. I've got another dead center which I've ground off of an 8 millimeter rod, and the reason for that is because that 8 millimeter rod is the same rod that I'm using for something else, like for another tool that I put in that tailstock. So I want to be able to quickly swap out those tools without needing to swap out the collet as well. If you're working on a larger lathe, a lot of people in larger lathes, they don't have collets in their tailstocks. They have Jacob's chucks, and that's not so bad because you can just quickly open up the Jacob's chuck and change out the bit from one to another. Maybe it's a centering drill, and then go to your normal drill, and then maybe to your reamer, and you can bounce between them because that Jacob's chuck is easy enough to swap out. But when you're starting to get into more precision work, a Jacob's chuck just isn't going to be accurate enough for the work holding that we're doing in the tailstock.
And I have to say too, your work on the Tripen posts paid off handsomely, or the Tripen tool holders for fitting onto the Tripen post. It was just delightful in the you don't even notice it sense of delight. As just work was excellent for being able to just easily take the wobble stick on and off of the cross slide. And just made working with it that much more fun.
Yeah, once you start working with a quick change tool post, it's tough to go back to anything else. And I've worked on lantern tool posts. I've worked on on just rests with where you're just using a hand graver on a lathe. And they certainly all have their advantages and disadvantages. But the biggest advantage with the quick change tool post is just effortlessly swapping between tools and not needing to worry about, is this thing centered again? Is it in the right spot? And that does make life so much easier. And having the wobble stick on one of those tool posts was really nice too. I was, I did put a lot of work into making that wobble stick so that it would be interchangeable like that. I didn't need to use a little rest or whatever. And I think that paid off. I think it helped with speeding up the process, and certainly was easy to use.
I think there were a few little things you picked up on, though, that you might do a little differently if you were to make a version 2.
Well, I certainly will be making a version 2 of it, and I haven't quite decided what I want to change up on it yet. I still need to do a little bit of work with it, I think, before I make the final changes to it. But certainly there will be another version of this before I'll probably do a video on it at some point about how I made this and what it looks like. But certainly there'll be a couple of changes to it when I do the next version of it. And speaking of that, it was certainly interesting doing a lot of work on this lathe. So this is a much smaller lathe than what I typically work on. It's something that I've worked on before, but I've usually been doing a single setup. So maybe it's turning a pin or turning a new staff or something like that, something which didn't need a lot of different sort of accessories on and off the lathe. And something that we had to do quite a bit on this was to swap out different things, whether it was the wobble stick, whether it was the cross slide, whether it was the tailstock. We couldn't keep the tailstock on while we were using the wobble stick because the wobble stick was long enough that it was extending past the end of the lathe bed. These are things that I'm not used to having to deal with, because on my larger lathes, it's easy for me to just slide the tailstock 20 plus inches away from the headstock, and I'm not worried about it interfering with the cross slide. Or when I bring the tailstock in, the cross slide doesn't get in my way because it's designed to stay out of the way of my tailstock. So it was certainly an interesting experience working with so many different accessories on this lathe, and the challenges of working on such a small lathe. And it's certainly doable, but it definitely slows you down as well.
It's interesting for me to hear that perspective, because I'm coming at it from the complete opposite side of that spectrum, where this lathe was notably bigger than what I'm accustomed to working on, because I'm usually working on an 8mm watchmaker's lathe, whereas this is a lathe that has 10mm collets on it, and like the bed, everything about it is just substantially bigger than what I'm used to working on. And that's substantial on a watchmaker's scale, because if walk downstairs and look at some of the other lathes that you have at your disposal, it's a totally different ballgame.
It's not very significant in terms of difference when you compare it to let's say the 16-inch South bend that I've got downstairs. Obviously that's a dramatically larger lathe, but still that extra little bit of space that you get, the longer bed, the wider bed, larger collets, the maximum size that I can hold in my 10mm collets is actually 8mm. So I can actually put an 8mm collet into my largest, collet and hold it.
Can eat my collets for lunch.
They certainly can, yeah. Which is, again, and that extra little bit of space, it makes a difference. You do end up with, slightly fewer problems when it comes with run out and things like that as well, because you've got a little bit more material to grab onto and stuff. So there are a bunch of advantages to having a slightly larger size. And I can certainly understand why a lot of watchmakers love the Shablin 102 as a workhorse lathe. It's certainly larger than you technically need. It's very similar in size to my Cromwell, which I work on a lot. But I can understand exactly why people go for the Shablin 102 versus the Shablin 70, because the Shablin 70 is very similar in size to my Derbyshire lathe, and that's a fair difference in size between the 102 and the 70, and just getting that extra space to work on, again, not having to remove the tailstock when you're working, being able to leave the cross slide in place when you're working with the tailstock. All those little things make add up to a huge time savings as you're working. And on top of that, you also get more rigidity, which means you're going to get more accuracy. And the dials are easier to read because they're larger, and the handles are a little bit nicer to work on because they're larger. All those little things really add up to having a more pleasant experience as you're working on these bigger machines.
Again, somewhat funny coming from the opposite side. Hearing you say extra space, extra space, extra space, whereas I've never felt so cramped trying to maneuver things, the little knobs on the back of the faceplate.
It's funny because the faceplate that's actually on here was originally mounted on an 8mm collet, and I picked it up off of eBay, and it was designed for it is a Derbyshire lathe chuck, but it was mounted on an 8mm collet, and I've made a new collet for it to get it onto this one, but I didn't quite appreciate how little space there was between the face of the collet chuck and the headstock itself. Again, I'm used to working on a bigger machine where there's a lot more space back there. Most of the bigger machines I have are also threaded in order to be able to accept chucks that you screw on something like a 3-jaw or a 4-jaw chuck, let's say. And so there's a lot more space in behind the faceplate than there is on the Derbyshire. So I need to make a new collet for the back of this in order to give us a little bit more working room, because you're right, it is very cramped back there with the existing setup.
But we got by. I'd call this first round a success.
Yeah, and something that Rich and I were talking about the other day was the what are we hoping to get out of this process, and do we plan on doing, a lot of watches like this? And I think the first thing to say is no, I certainly don't plan on trying to make a lot of watches like this.
You can't make a lot of watches like this.
You're right, you can't. It is very slow, and it is nice to do it this way. Like, it is nice to see how can you make a precision machine, a watch, with a relatively primitive setup, something that you could set up in, a closet or a spare bedroom or whatever, right? And so you could understand how a watchmaker 200 years ago would be able to actually make a precise machine in a relatively small setup in their, in a small back room or whatever in their farmhouse. So it is nice to be able to see how that works, and to know that if I needed to, I could set this up on a bench in a spare room and actually be able to make a watch out of it. Again, it's not something that I would want to try and make more than a couple of. It's certainly slower, and there are a few things that will be changing up in order to make a couple of these in the future. As we finish some of our experiments, I think we do want to try and make more than just one or two of any of these movements. And there certainly are a few things that we can do to speed up that process in the future.
Mm-hmm.
And even though there are things that we can do to speed up that process, we'll still be able to maintain the sort of the feel of making these watches individually and sort of quote unquote by hand. We can do things like using a pantograph in order to cut out the bridges instead of cutting them out by hand with a jeweler's saw. We can use a drilling machine to speed up drilling some of these holes that we're working on. Not necessarily, we don't need to necessarily go all the way into CNC machining to be able to do this stuff. There are ways of using manual machines to be able to speed up that manufacturing process. So we can sort of produce a small serial number of watches at a time, while still maintaining that essence of what it is that we're doing.
Certainly for the better part of a century or more, really, that's how the watch industry operated.
Mm-hmm.
CNC machines didn't debut until we had computers to numerically control machines. They didn't exist before. So there are all manner of tools and operations that were done old school. And
it is nice to see how those worked and to see how to actually get to that level of accuracy. And because we think of today's precision machines and we're like, well, how the heck could you possibly, work on a relatively primitive lathe and get a precise thing? But when you start learning about things like turning between dead centers and using face plates and wobble sticks and things like that, you start to very quickly realize, oh, okay, there are ways of being able to actually do this work and be able to work precisely, as long as you are intentional about what you're doing and you understand exactly where the inaccuracies are going to come from the work that you're doing.
Mm. Yeah, you're not going to achieve the speed and precise repeatability of something like you'd get from a Pressy tram.
Sure.
But you are still able to, with time and patience, get very precise results using very primitive tools.
Yeah, absolutely. And it certainly shows me that the people who are interested in trying to do some of this work at home in their home shop or whatever, it's certainly doable. There are, 8mm watch lathes are certainly common enough on the internet. You can find a reasonable one on eBay. The tooling that we're using, again, I'm using a 10mm lathe, but you don't need to. You could use an 8mm lathe. I have some nice machines for being able to make my life easier when I'm working, but they're certainly not necessary. You could easily do this work in a spare bedroom with more primitive machines. Don't even need an electric motor. You could even use a bow-driven lathe.
Or bow-driven. Yeah. So next up, we'll be turning up some pins to put in these holes that we've just drilled. And where do you want to take things from there?
Yeah, once we've managed to get the pins turned up, we can separate the two plates now. We had actually glued them together using CA glue. And now that we've drilled the holes for the pins, we can actually separate those, turn up some pins, and insert the pins into the new bridges and plates. And then from there, the next thing we need are holes for the screws, because we need to be able to screw these plates together and hold them together for some of the future work, things like separating the bridges, because at that point we can then start talking about cutting the bridges into separate segments, and then we can start going down the rabbit hole of things like jewel holes and whatnot. The next step is pins so that we can hold them together, hold the plates together, and reference them against each other appropriately. But we need to be able to hold those things together. So we'll definitely be drilling out some screw holes. And the nice thing about these ones is that these are just clearance holes. We don't need to worry about tapping these holes because tapping at the scale, as we've mentioned before, can be fun. But these are really just clearance holes and also some countersinks so that we can have somewhere for the head of the screw to be able to sit inside of that plate.
Well, thankfully, as far as watches go, these are quite large screws.
Oh, yeah.
So it wouldn't have been too bad tapping these holes. It would have been
No.
Fairly straightforward. But we will certainly be getting more intimate with the wobble stick once again.
Yeah.
Plenty more holes to drill.
There are a couple of holes that we will have to drill and tap at some point, including a reverse thread, which will be interesting. It's been a while since I've done a reverse thread with a tap, and this one is significantly smaller than the last one that I did. So we'll see if I manage to snap a tap just because I managed to turn it in the wrong direction. It'll be interesting, and again, as you say, a lot of wobble stick work coming up as well.
Thanks for listening to Off Hours. You can find detailed show notes at offhours.show. If you'd like to keep up to date with the show, follow us on Twitter @offhours. Jon can be found on Twitter @UnderTheLoop, and Chris can be found on Twitter and Instagram @silver_hand.